Hi, welcome to Cybersecure channel. I'm glad to share that recently I have acquired Certified Kubernetes Security Specialist certification. It was an awesome yet a gruesome process. No doubt it is the toughest of Kubernetes certification. But don't worry, I have you covered through this particular video. I will share my exam experience and tips on utilizing your time effectively. Secondly, this video will serve as a ready reckoner for the exam day where you can revise all the important topics in a short time. I hope this video will help you in acing CKS exam. So without further delay, let's start. CKS is a performance-based certification exam that tests candidate knowledge of Kubernetes and cloud security in a simulated real-world environment. Curriculum outline of the knowledge, skills, and abilities that a certified Kubernetes security specialist is expected to demonstrate is broadly divided into 6 domains as flashed on the screen. First domain is cluster setup, having 10% of weightage comprising of CIS benchmarks, network policies, ingress objects, minimizing GUI access, and verifying platform binaries. Starting with CIS benchmark, which provide prescriptive configuration recommendations of best security practices. In exam, you will be asked to secure kubelet by stopping anonymous authentication and authorization. Similarly, you may be asked to enable some features in Kube API server or Kube controller. You need to know the location of the configuration file as flashed on the screen. Network policy enforces how a pod is allowed to communicate with various other network entities. For example, you need to know the default deny policies of ingress and egress. It is already in documentation, no change is needed. To implement other policies, you need to find labels of the pods or the namespace through ---- show label command, as shown on the screen. An ingress object manages external access to the service in a cluster. If there is an ingress question, use the imperative command as flashed on the screen. TLS secret can be incorporated as shown to enable HTTPS secure communication. GUI access can be minimized through role-based access control of the service account used in Kubernetes dashboard. Imperative command for implementation of role-based access control is flashed on the screen. To verify platform binaries, hashes of file can be utilized to confirm their legitimacy. For comparison of hashes, use grep command as shown on the screen. Coming towards the second domain is cluster hardening with 15% weightage comprising of restricting access to Kubernetes API, role-based access control, secure usage of service accounts, and updating Kubernetes. When a request reaches API, it goes through several stages illustrated in the diagram. First, object is made accessible through a network policy. Authentication process can be completed through a client certificate, password, or token. Kubernetes supports multiple authorization modules such as attribute-based access control, role-based access control, and webhook. We normally use role-based access control for authorization. Admission control module can modify or reject a particular request as per defined template. It can be validating, which is to check the presence of an object like a namespace, or mutating, which means allocating a namespace if not defined, or a combination of both. Kubernetes auditing provides a set of records documenting the sequence of action in a cluster. Now, coming towards the role-based access control, the role always set permission within a namespace in which role is created, while cluster role is a non-space resource and applied on whole cluster. Always use imperative command for implementation as shown on the screen. Auto-mounting of service account credential can be disabled using the command on the screen. Further, it is highly unlikely to get a cluster upgrade scenario in CKS exam. It is more related to CKA. However, after completing the steps in the documentation, command flash on the screen can be used for the verification of the versions. Coming towards the third domain, which is system hardening with 15% weightage covering minimizing operating system footprints, minimizing identity and access management roles, minimizing external access, and lastly, kernel hardening through app armor and seccomp. To reduce OS footprint, first we can check the installed packages through apt command, then check the service status, then we can stop and ultimately remove the package through the command shown on the screen. For minimizing identity and access management role, we can use user add and user mod command. First command, create a user SAM, assign a working directory, a shell access, user ID, and group. And second command is used to deny shell access to user Jack. For minimizing external access command, allow the passwordless access to a user gem in the node 01, while the path of sssd config and sudo is also shown on the screen, where you can change the settings of a particular user and controls its external access management. ls mode can be used to list the loaded modules in the kernel. Mod probe is used to blacklist a particular module through the path shown on the screen. Seccom can be used to sandbox the privileges of a process, restricting the calls it is able to make from user space into the kernel. Path of the profile is shown on the screen, and it can be enabled through security contexts. AppArmor is a Linux security module implementation that restricts implementation's capabilities and permission with profiles that are set per program. A default path is shown on the screen. Profile can be enabled through AppArmor parser command. Status can be checked through AppArmor status, and profile can be implemented in pod through security context. Now coming towards the fourth domain, which is minimizing microservices vulnerabilities through OS level security domains. Management of Kubernetes secrets using container runtime sandboxes like gvisor and Kata, and implementing pod-to-pod encryption using MTLS, which is mutual TLS. To implement OS level security, we can use netstat command to check which application is using a particular pod. Then we can check the process ID of the application through psaux command. After knowing the process, we can kill and remove the binaries through command shown on the screen. We can get the base 64 decoded secrets through command shown on the screen. You can find this command in the cheat sheet of Kubernetes documentation by searching the secrets. A runtime class can be implemented in pod through command shown on the screen. And it can be implemented through runtime class template by defining the name of the runtime class, and the handler for gvisor in this example is runsc. Mutual TLS between Kube API server and etcd can be implemented through command shown on the screen. First command is for Kube API server, and the second command is for etcd. Coming towards the fifth domain, which is supply chain security, with 20% weightage covering minimizing base image footprints, securing through whitelisting registry and images, static analysis of user workload, and scanning images for non-vulnerabilities. If we want to use a private Docker repository for images, we have to first define the secret through command shown on the screen, and then implement it on pod through image pull secrets command by specifying the particular secret. Whitelisting of registry and images can be performed through image policy webhook, where you first define configuration file, then config file and webhook server. Then implement few settings on Kube API server through admission, plugins, and configuration file. Static analysis of YAML file before implementation can be performed through kubesec or manual scan. Kubesec automatically identifies vulnerable configuration and defines scoring system to evaluate the YAML file. Images can be scanned through trivy command. In order to retrieve list of images in particular namespace, command is flashed on the screen. It can be found in the cheat sheet of Kubernetes documentation. Last domain is monitoring, logging, and runtime security with 20% weightage covering behavior analytics of syscall and file activities, ensuring immutability of containers, and in the end, audit logs. A system call is a programmatic way in which a computer program requests a service from the kernel of the operating system where it is executed. Stress command can be used to check the interaction of a program with the kernel. Different variation of usage of the command is flashed on the screen. Immutable infrastructure refers to environment which cannot be changed once deployed. By preventing or identifying unauthorized changes, immutable infrastructure make it easier to identify and mitigate security risk. It can be ensured through security context by disallowing Privilege escalation, read-only access to root file using non-root user and removing any special capabilities assigned to the pod or the container. Auditing allows cluster administration to answer questions like what happened, when did it happen, who initiated it, where was it observed, from where was it initiated, to where was it going. It can be enabled through defining audit policy and configuring Kube API server accordingly through commands shown on the screen. Lastly, Falco provides near real-time threat detection for cloud, container, and Kubernetes workload by leveraging runtime insight. General CTL command can be used to get the real-time insight, while the rules for detection are present at etc Falco. Sysdig is another tool used for same purpose. To get event first, we list them and note down the relevant supported event and get the output through sysdig-p command by specifying the event and container name. In the end, some suggestion during exam. CKS is a 2-hour proctor exam that requires solving tasks via terminal running Kubernetes. There are total 16 questions, which means we have 7.5 minutes per question. It is therefore important to prioritize question and solve relatively easy question first. Keep in mind the context. Questions solved under different contexts will bear no credit. Practice hard with killer coda, killer.sh or on cluster environment so that you maintain low dependency on documentation due to time scarcity during exam. In the end, don't lose hope. If you fail on first attempt or find the topics difficult to digest, it is a difficult exam and requires due respect. I hope I was able to guide you guys for preparation of CKS exam, and this video may serve as a ready recknor for your exam preparation or revision. Thank you very much.